Okay, our final video on major study designs and study methods for the health sciences is going to focus on the more analytical observational epidemiology studies, notably case control studies and cohort studies. So we're going to also do a little review here before we jump into the case control study design. So first four questions. True or false, going back to the cross-sectional studies, they are employed for identifying causal mechanisms of rare diseases. Is that true or false? So you should have said false because you'd need to survey like 1 million people to get something like pancreatic cancer. So it's not very good for that type of study. True or false, the unit of analysis in a cross-sectional study or in cross-sectional studies is the individual. The unit of analysis in cross-sectional studies is the individual. You should have said true because ecologic studies are the ones where it's at the population level. Cross-sectional studies, like we're going to talk about here, case control studies, cohort studies, clinical trials, all of those gather data at the individual level. All right, number 3. Ecologic studies are effective in identifying the causes of disease. So ecologic studies are effective in identifying causality. Is that true or false? You should have said false because, again, we gather data at the population level that may not always hold true at the individual level. So more analytical epidemiology designs are a lot better at helping getting closer to the true cause of disease. Number 4. A description of a rare disease in an individual is defined as a, so what type of descriptive study did we describe earlier? Probably not so much from a statistical standpoint, but just basic epidemiology study design. And a single rare disease would be a type of case study, and we would just call it a case report. All right. So what are the 3 types of observational studies described so far? Well, we mentioned the case studies. We've also mentioned cross-sectional studies. We've also mentioned ecologic studies. We've got a few more. You should remember that the ecologic fallacy is when something is maybe looks like a relationship on a graph. Like there might be a regression analysis that shows a relationship, but assuming that that relationship holds true at the individual level when in fact it does not is the ecologic fallacy. A goal of an ecologic study, what is the goal? Why do we do them? Well, they're easy for us to show potential hypotheses, but the goal is to maybe develop or demonstrate potential hypotheses of things that may be happening at the individual level that could be happening also at the population level, and it's just maybe for hypothesis generation. The type of studies that gather individual level, what type of study gather individual level at a single snapshot in time? So we survey people, we get individual level data at a single point in time. What type of study would that be? The best answer for that would be a cross-sectional study. Next, if given data, you should be able to identify if it's individual level or group level data. So if you look at a spreadsheet that's got some rows and columns and questions in there or variable names in there, you should be able to identify if it's ecologic data or some type of individual level data. And you should just briefly, it's always good to just be familiar with the different designs. So we've spoke a little bit already about some observational epidemiology, particularly the more descriptive kind like case studies, cross-sectional studies, and the correlational ecologic studies. We've also spoke some already to experimental designs like analytical and analytical designs, particularly the clinical trials or the community trials, where data are collected at the individual level and exposures are assigned and outcomes are measured based upon whether or not they had the exposure or not, and we can make all those kinds of comparisons. Where we're going to go to now for the next 10 minutes are analytical observational epi designs, specifically the group of case control studies, which includes case crossover, case control, and the nested case control studies, as well as cohort studies. And We will jump into the case control design first. A case control study design is one in which the presence of a risk factor or risk factors for persons with a disease or a condition, and those are our cases, is compared to those who do not have the disease or the condition. So we may be interested in people who have a heart attack or who had a heart attack in the last week, and then we find people at a hospital, the same hospital, who may be there for something else. Those are the controls. There are a few different types of case control studies. The traditional one that I just kind of spoke about. There's a nested one where we might do a cohort study and then people become positive and then we kind of do a case control study within a cohort study. There's also this other one called the case crossover study where the cases serve as their own controls. We'll discuss that one here in a minute. Cohort studies, they are different than the other designs in the sense that we are still gathering individual level data. They are observational in the sense that we're not assigning exposures, but what makes them really different the most is that we do some sort of follow-up where people may be enrolled in a study at some point or they have some entry point and then we know something about them at different points in time and we know something about when they were exposed to things and then when the disease actually arrives or becomes a new case, an incident case of disease or an incident case of the condition of interest. So cohort designs, we have to know when they were healthy and susceptible and what that time was at the beginning of the study, and then we follow them through time. We often think of following them in time forward to figure out the incidence of disease, when the new disease started. And then throughout that time, we also know something about their exposure history or their risk factors associated with the disease. And the most common one we think of is the prospective design, but if you've got records on the individual, you can go backwards as well, or forward and backwards from a specific point in time, as long as you know when they were healthy and susceptible to disease. So with regard to the case control studies, you have to have a definition for what makes something or somebody a case. Maybe these people are in a hospital registry as having a particular disease like a cancer. Then you have to have your controls, and your controls should have as much as in common with your cases as possible, except for maybe the exposure that you're most interested in. So maybe it's a particular type of occupation. So how do you match your cases up with your controls? Well, you might match them or find people at the same hospital. Maybe they're not there with the cancer, they're there for a heart condition, or there because they had a broken arm or a broken leg. So selecting controls is always tough. From a statistical standpoint, we're not so much worried about that for this class. And then we also have to know something about being able to categorize their exposure. So were they exposed to some sort of chemical, or did they have a job or not a job? Were they smokers or not smokers? That kind of stuff. Then with case control studies, we can calculate an odds ratio. And there's a few videos on how to interpret odds ratios. So an example from a paper might be something like this. This paper is the effectiveness of helmets in skiers and snowboarders. And then they do a case control and a case crossover study. You see this abstract here. We've got 1,000 skiers and snowboarders with head and neck injuries reported to the ski patrol. These are our cases. And then there were other things reported to the ski patrol, but these were for 3,295 skiers and snowboarders who had non-head injuries and non-neck injuries, and they matched them to each hill. So we have our cases and controls, and they're all, injuries reported to the ski patrol. It's just the cases had head and neck injuries and the controls had other injuries. And they were interested in figuring out if helmets actually had any impact on the risk of having a head or neck injury among these skiers, snowboarders across these 19 areas in Quebec, Canada in the early 2000s. So you'll see in papers, you'll get your descriptive statistics on the frequencies of which people had the different conditions, and then you'll be able to see how they actually calculate the odds ratios. So we will be doing logistic regression later in this class, but there's a nice video or series of 3 videos on how to interpret odds ratios. So you should be able to, upon watching those videos, look at these and see, oh, 0.81, that effective helmet use, this seems to be protective at preventing against any head injury. However, it just barely misses statistical significance. If this makes no sense, you'll want to watch those videos and be able to make sense of it. You'll want to be able to look at something like this and see the 0.71 and say, oh, that's protective. Helmets are protective because this is less than 1, and the entire confidence interval is less than 1, so it's statistically significant, and the p-value associated with that would be p is less than 0.01. So that would actually reduce the odds of a head and neck or a head injury by helmet use by 29%. So those who wear helmets are 29%, have 29% lower odds of a head or head injury compared to those who do not wear a helmet. So here's just an example. People who are divorced have maybe an odds ratio of 1.33 for some condition in some case control study. You have a p-value of 0.696. It's not significant. The confidence interval goes on both sides of 1. So you should be able to look at those videos and be able to make interpretations about odds ratios, which are the standard measure of association or lack of association from case control studies. We'll focus on those a lot more here in the future when we do logistic regression later in the course. So it says here the p-value for this ratio is 0.696. Is it significant or not? Why? Why not? You should be able to answer that upon watching those other videos. You have the confidence interval there, 0.31 to 5.6. Again, you should be able to use all this information to be able to determine if something is significant or not. And we'll have more videos on that as well as watch those other videos. So case crossover studies, they're similar to case control studies except for the cases serve as their own controls. So rather than having people at the hospital on the same day for a different condition like a broken arm to compare against people who had a heart attack, you may have people who actually had a heart attack and then you use those same people 7 days earlier. This is really common with air pollution studies. So these people were exposed to a smog alert 1 day before their heart attack. These people were not exposed to a smog alert 1 day before their heart attack. These same people 7 days before their heart attack, this is their control. Was there a smog alert that day? And then was there a smog alert 7 days before their heart attack here for this group? So all this is just a little intro into the case crossover design. This isn't an epi class. It's just letting you know that there's a variety of study types out there that we can look at through statistics. Case control studies are really good for studying rare diseases, and we'll use the odds ratio a lot for that, as well as maybe chi-square testing or Fisher exact testing. They don't require a lot of money or time compared to cohort studies, which we'll talk about here maybe in one more video. I thought we were going to fit it all in on this one. And the case control studies give us an odds ratio, and the odds ratio, you'll learn later on in the course, is a pretty good estimate of risk when a disease is rare. These studies do have their limitations in that, we can only focus on one condition, understanding the sequence of event to disease, like exposure to disease. People may forget what they were exposed to. The people who are sick may remember better compared to the controls. Who participates, who you select, who's alive to participate, all that matters. So next we're going to do cohort studies. So that concludes the case control video.